Good day, everyone. Today we're going to talk about sidecars, eBPF, and the future of service mesh technology. My name is Jim Barton, and I am a field engineer with Solo.io here in North America. Solo is a company that's very passionate about application networking, especially in a cloud-native context, and we support a number of the largest and most influential projects, open source projects in that space, things like Istio and Envoy Proxy, as well as other projects like GraphQL and Cilium. I wanted to set the stage for this story, or for this presentation. I want to take you back to something that happened just a few months before my graduation from engineering school a long time ago. As you can see in this picture here, I had a lot more hair and was a little thinner back then. And so this story goes back to a competition that was held with my IEEE student chapter, actually multiple IEEE student chapters from around our region. They got together and had a contest that was a robot car racing contest. So you had a car that was to trace a line, very much like what you see here in the picture. And the idea was to go as fast as possible and to beat out all the other schools. And so this was a high energy competition that had a lot of entrants from a lot of different engineering schools, a lot of really interesting designs. Most of them were fairly complex. Some of them were a little funny. But at any rate, to boil it all down, there were two designs that kind of worked their way through this single elimination competition. And so one of them was this huge behemoth of a design. It had this giant central core and these rotating legs that kind of came off that central core, each with their own wheels. And so this superstructure would rotate and would kind of propel this vehicle down the little black path there. And so it came from a very large, very well-respected engineering school, had a big following with it, a big operations team, and was a pretty impressive thing to watch. Well, as the competition went on, so this entrant went all the way to the finals, but then there was kind of an underdog that went through to the finals as well. And it was pretty much the polar opposite of our giant behemoth. It was a little tiny entrant from a small engineering school. They sent a single delegate to this convention, and he built this thing. It looked like it used the chassis of a child's slot car, and had a little tiny sweeping photo detector at the head of the car with a little battery and a little motor to drive things. And it just kind of swished its way down the track and was beating all of these much bigger, much better funded competitors. And so we got to the end of the competition, and there were two finalists left standing. The big behemoth with the giant rotating legs and the D-cell batteries hooked into the superstructure against the little tiny one designer slot car, right? And so I learned a lot of things my senior year of college, but that particular day taught me a lesson that I have never forgotten, and that is the lesson of parsimony. Parsimony simply being the law of simplicity. When you have a design goal in engineering and there are multiple paths to get there, all other things being equal, the simplest path, the fewest moving parts are generally the best. And so as we transition into discussing the future of service mesh, the way that I see the trends in the marketplace right now, it's all about simplicity, recognizing that we need to move toward more simple designs of our service mesh technology. And there have been some really, really exciting developments in that space just within the past month or two. And so we're going to talk to you about that as we go forward. So to kind of set up that discussion, let's go back to the beginning, quote unquote. Let's assume you're living in prehistoric times, let's say 2017, right? Prehistoric times, and you have services that need to communicate with each other, right? So before there was service mesh technology, you might have, two services, service A and service B. And let's say you are a financial institution or a government entity or in some other industry like telco that's heavily regulated. And maybe you have a requirement like, well, all communication between all services need to be encrypted, and you use MTLS technology, okay? And so let's say that requirement was presented to you in these prehistoric times. How might you fulfill that? Well, you'd go out, you'd Google, TLS libraries for whatever kind of, language service I'm using, and maybe you'd integrate that and you'd test it out with the service or services it needed to communicate with, and you'd deploy it, and everything would be fine. And so that approach is fine as far as it goes, but the problem is there aren't many of us sitting in on this session who live in such a small scale environment. We often live in environments that look something more like this. I spent a number of years at Amazon, and we actually had a chart that was on a lot of walls in a lot of places that we called the Death Star. And the Death Star showed, at some snapshot in time, all of the various service, microservice interactions that were happening within the Amazon application network. And so this simple approach, where sort of each application dealt with its own, let's say security infrastructure, metrics production, advanced routing capabilities, that sort of thing, it really didn't scale very well into an environment like this. And so it caused us to ask a number of questions about, if we want to build microservice networks at scale, how can we best answer questions like this? How do we secure communication between services in a repeatable, reliable fashion? How do we manage things like timeouts and communication failures? How do we control and route our traffic? How can we publish consistent metrics? How can we observe interactions among all of these various services? And so we began to realize collectively as a community that a lot of these concerns that we talked about here are actually cross-cutting, right? They apply to all of these services. And so wouldn't it be good, rather than building this kind of undifferentiated heavy lifting logic into each and every application, what if we could externalize that in some way and handle these cross-cutting concerns in some piece of infrastructure, right? And so the first architecture that came out of just about every service mesh platform in that era was through something called sidecar injection. You kind of see that depicted here, where there would be a sidecar injected that lived next to the application code in question, and would actually manage these kinds of connect, secure, observe concerns on behalf of the application. So there you can see some of the very common capabilities that evolved or that were design goals for this first round of service mesh technology. Again, the key, we won't go through all the details, but the key pillars here being connect, secure, observe what's going on inside your complex application network. Okay. And so we ended up with, whether we're talking about the Istio service mesh or a variety of other service meshes that are out there, a lot of them operated along this same basic architectural line. And so that is, there are two components. There's a data plane component and a control plane component. So the data plane component is actually responsible for the processing of the request. And so what would happen is, at some point, an Envoy proxy would be injected into each one of those services as a sidecar, and the sidecar handling all of these cross-cutting connect, secure, observe concerns. And so when an application needed to talk to another application, say service A needs to talk to service B, then those kinds of issues, metrics publication and failover and timeout and that sort of thing, could all be handled by these Envoy proxies that would intercept all of the requests going in and out of various service components. And so that was a way to achieve, let's say you have a security mandate. So you have a security mandate, and by simply injecting these sidecars into your applications and applying some very simple policies, then you could guarantee that your network of microservices was using proper security practices to manage traffic inside the mesh. Okay, and so that's the data plane. Well, the data plane also depends on a control plane. So the control plane is the brains of the operation. So there is some outside stimulus that comes in. Maybe it's a kubectl command, or it's an Argo controller that's applying configuration, something like that. That's actually specifying what kinds of policies we want to apply within our service mesh network. And so the control plane then is responsible for taking those policy specifications, translating those into configuration for the various Envoy proxies deployed in all of the services around our network, and making sure that those are distributed, those Envoy configurations are distributed properly out to the various services so that those policies can be enforced in the best and proper place. And so that's been the general state of the service mesh technology for a while now. And so let's be clear, there are a lot of people who have been and who are very successful using this architectural approach, because it does solve a lot of problems. There are a lot of cross-cutting concerns that are able to be absorbed into the mesh components, so that work no longer has to be done in the application code itself, which is a very good thing. But there are operational challenges that have arisen as we've gained experience over the intervening say 4 years since Istio went 1.0 GA release in 2018. Over the intervening years, we've learned a lot. Okay, and so this is a great quote from a very senior engineer at T-Mobile named Joe Searcy, and what he said: the biggest enemy of service mesh adoption has always been complexity. The resource and operational overhead to manage the service mesh for a large enterprise makes adoption cumbersome, even as projects like Istio have worked to decrease complexity. All right, so we're talking here about this particular approach. While it does remove a lot of cross-cutting concerns from the underlying application, it can be fairly complex to administer, especially at scale. So let's talk about briefly just a couple of those issues, and then we'll talk about some of the innovations that are going on right now to address that. So from an operational complexity standpoint, so this shows you a typical Istio sort of deployment, obviously simplified quite a bit, but you can see we have 3 nodes that are deployed presumably in our Kubernetes cluster. There are a number of apps that are deployed, some of them with multiple instances. And because we're using Istio, we have an Envoy proxy sidecar that's injected into each one of those application pods. Now, there are issues that can happen. Let's say because these components, the application workload and the proxy, live in the same pod, there can be issues when you're trying to let's say you're trying to take down a service, maybe to apply an update to the underlying workload software, maybe to apply an update to Envoy itself, or to Istio data plane. So there can be issues like, for example, let's say the application comes up first, app 1, and the sidecar, there's a race condition there. The sidecar hasn't quite made it yet, and so the application starts to try to do its thing to fulfill its mission, and it sends out requests, but there's no sidecar to intercept that request and apply whatever policies are relevant. And so as a result, it may spew a number of failures as it's in this kind of race condition startup phase. So that's not a good thing. There's converse sorts of problems that can happen when services are trying to shut down, and so forth. So this kind of race condition that's an artifact of the fact that we've injected this proxy into the pod is something that we'd like to avoid if possible. Also, applications have to sometimes, although our goal is for applications to not be aware of the mesh, in fact, sometimes it does need to happen. So, for example, here's a case where we have a pod that spins up a job. And so this is a job that's going to run for some period of time. It completes its mission, and then it shuts down. Well, so we have operational issues like when that job shuts down, you can have conditions where perhaps because the sidecar is still running, right, that pod is not cleaned up properly. Those resources are not cleaned up in a proper, timely fashion in order to use those resources as efficiently as possible. And so that's something we'd like to address as well. There's also a very popular topic of latency. So what happens here with our sidecars is those are injected into the application workload, and those sidecars have obviously certain latency that's associated with them. And so these are fully configured Envoy proxies that live as sidecars in Istio. And so they have a full layer 7 TCP stack that has to be traversed every time traffic goes in or out. So you can see you get some latencies that build up going from, the application to its sidecar, then to another sidecar, and then to the serving application. It can be a few milliseconds of processing time, and that's something we'd like to improve as well. And then finally, from a cost standpoint, well, all of these Envoy sidecars that we are provisioning, they cost money, right? They cost memory and CPU and actual money. And so one of the things we would that we see in our business as we talk to people is that often, because you don't want these sidecars to be under provisioned, right? Because that creates issues. And so what happens is often people tend to over provision the sidecars, give them more capacity than they need, and that actually results in an unnecessary spending of money, which is something we would like to avoid as well. So those are some of the challenges. Again, this model has worked very well for a number of years, but there are some challenges, and we'd like to be able to address that. And so the folks at Google and Solo have been talking about this problem for roughly a year, maybe a little longer now, and have just contributed in the September timeframe to the Istio project a new sidecar-less data plane option that allows service meshes to operate completely, if that's what you want, without sidecars. Okay, and so that has a number of really important implications that we'll be talking about over the next few minutes. Things like cost reduction and simplifying operations and improving performance. So we will talk about all of those. One of the things from an operational standpoint that you see is it's much easier to get started with Istio Ambient Mesh due to the simplified onboarding process. So when you were working with, say, in a sidecar mode, obviously every workload in a namespace that you wanted to put, to include into the mesh, you have to go inject sidecars into each one of those, and that's it's a decently heavyweight process. Whereas with ambient mode, it's simply a matter of kind of labeling your namespace as being, hey, I want this namespace to be something that participates in the mesh using ambient mode. And what happens is the appropriate infrastructure will get spun up to make that a reality, but without any change to the underlying workload itself. You'll see that in the demonstration in just a few minutes. And similarly, if you want to take things out of the mesh, it's a very simple process where you're just simply taking away that infrastructure. The Istio CNI will change some routing rules, and basically the underlying workload itself remains completely untouched. So pretty good stuff. So the way that this works, how this works is you can, there are two layers to the Istio ambient mode, two new layers that you can use. And by the way, these modes can interoperate with each other as well. So you can have, if you have existing workloads that operate in a sidecar fashion and you want to spin up, let's say, new services that operate in ambient mode, those two can interact with each other. There are no issues there at all. But going forward, we actually see a lot of the we anticipate a lot of the new adoption in Istio. Once Ambient is really fully production ready, we see a lot of new adoption going in this direction. By the way, on that note, so ambient mode is available in Istio 1.15 on an experimental, basically on a beta sort of basis. So it's not considered ready for production use yet, but we are moving up the experience curve very quickly and expect it to be a predominant deployment model going forward. So what we actually get when we add ambient mode to a namespace, what we actually get are potentially two different sets of components. So there is a secure transport layer that operates on a per node basis that handles just level 4 issues. So its primary purpose is to manage securing traffic between workloads. We'll show you that. We'll show you a picture of that in just a moment. Then in cases where you also need layer 7 policies, so things like, let's say things that require HTTP headers, maybe redirects and retries and fault injection and advanced load balancing, those sorts of things that require layer 7 HTTP access, those policies will be delegated off to a separate set of layer 7 proxies that we're calling waypoint proxies. So two layers here. One is zTunnel that handles primarily level 4 security, MTLS kinds of concerns, and then a second waypoint proxy layer that operates at layer 7 and handles the higher level set of concerns typically associated with HTTP. Okay, but in terms of the control plane architecture, as you can see there at the bottom, that's unchanged, right? Same APIs as before. The control plane is the same old Istio-D control plane that you may have used if you've used Istio in the past, and it will program the zTunnels and the waypoint proxies exactly the way it's always programmed sidecars, and will continue to program sidecars in the future. Okay, so those are the two layers of the ambient architecture. So what you see with a request, so let's say we just care about, let's say, establishing MTLS through our network, and that's a common adoption pattern that we see for Istio. People often don't want to bite off on the full kind of connect, secure, observe, all the features of Istio initially. A lot of times they come to us with a mandate, like, for example, federal agencies, public sector clients come to us with a mandate, say from the Biden administration, that we have to use MTLS security among all the applications in our mesh. Okay, and so we do that here with this zTunnel component. And so what's going to happen is if app A wants to talk to app B, the request goes to the zTunnel. The zTunnel then directs that to the zTunnel where the target application is, manages the communication, the request and the response back and forth between the two, and life is good. Okay, so it's very possible then to do this sort of incremental adoption of Istio using ambient mesh, where if all you care about is MTLS, you can get by with just these very simple per node deployments that are not injected as sidecars into your applications. Now, if layer 7 policies are needed, and they often are, then we're going to introduce the notion of a waypoint proxy, where you can provision these proxies as you want. They don't have to be on any particular node. You can provision them using standard, Istio service deployments, and they're going to handle all of the layer 7 kinds of policies that need to be applied to a particular request. Now, you don't have to worry about the details of how these proxies get programmed. Istio-D control plane is going to take care of that for you. You simply specify via the API what you want done, and the control plane is going to make sure that the proper components are programmed as they need to be. So those are the two layers, and we see from a benefit standpoint, we see right off reduced cost. That one's a pretty obvious one, right? So instead of having, in this case, we got 12 workloads across 3 nodes, each with their own layer 7 proxy, we can now eliminate those proxies in favor of an approach that uses, again, if we're doing just security, we can do just a sidecar proxy I'm sorry, a proxy per node as opposed to a sidecar proxy per pod. So it really reduces the set of infrastructure that is required there. And in doing that, we see some pretty dramatic cost reductions. You can actually go visit this blog if you'd like to explore this in more detail. bit.ly/ambient-cost will take you there. But just to give you the kind of the conclusions of this, comparing the sidecar approach to the ambient approach, especially for cases where you're doing incremental adoption of just the security features of Istio, you can see pretty dramatic, in some cases like 75% reduction of the amount of CPU and memory required to accomplish the same objective. So going back to our original theme of simplicity, right? We're trying to make this new model as simple as possible. So another thing, and this is perhaps the most significant benefit of the ambient architecture from what people are telling us, is the potential for simplifying applications. So we've talked about some of the issues around upgrades and around adding new applications or taking things out of the mesh. This becomes a much, much easier process now, right? We don't have to, if we're doing some kind of a rolling upgrade, say there's an Envoy CVE at layer 7, and we need to roll that out throughout our service mesh network, we don't have to go take down every single workload that's in the mesh in order to make that happen. We can simply do an update at the proxy layer, and immediately those changes will be visible to the entire mesh without the actual applications being impacted. So that's a huge benefit here. And so we can see this graphically here, where this is sort of our initial pre-ambient setup. And if we just need the security components, we could go to something like this, where we have just, rather than one sidecar per proxy, we have one per node where workloads are deployed, and those are not injected as sidecars. They are their own standalone Z-tunnel deployments. And then if we need the more sophisticated layer 7 processing, we can add that as well as a separate set of deployments, and we can scale those up independently of one another based on how much traffic we anticipate to be going to the service account in question. Okay. From a performance standpoint, just a very simple analysis here that I think nevertheless illustrates what's going on. So we have these Z-tunnel proxies that are configured with Envoy and layer 4, right? And so just because they're just dealing with the bottom level of the TCP stack, they're much more efficient than if you have to go through the full layer 7 stack. So we anticipate the proxy overhead of these layer 4 proxies about a half millisecond, back of the envelope on average. Layer 7, so the waypoint proxy is typically 2 milliseconds of latency added. And so you can see, no mesh is obviously the baseline case. There's no proxy overhead there. But in the traditional model with L4 plus L7, and you're guaranteed to have to traverse 2 of these proxies on each request response, that's about 4 milliseconds of added latency. Whereas if you're just doing layer 4, again, secure communication, that can be as low as 1 millisecond of overhead, or with the full layer 7 policies taken into account, even there's typically a significant reduction, say from 4 to 3 milliseconds. So we think this is something especially applied at scale where people are going to see pretty dramatic differences in performance, cost, and operational overhead. Okay. Now we're going to switch over at this point and show you a demo of ambient mesh in action. So we're going to start by installing Istio. If you come here and look at our cluster, we don't have Istio system installed. We have a handful of applications, some very simple sample applications that we'll use to demonstrate this capability. So the sleep service here, if we exec into this, we can call hello world and get a response from one of the services. And in this case, I see it load balancing between V1 and V2. I can even call a specific version if I want, and I can call the other version as well. But what we want to do is we want to install Istio, and we want to implement service mesh capabilities without having to deploy a sidecar. So let's come over here and we will run Istio install. We'll run it using Istio CTL, and we will set the profile to ambient mode. So let's take a moment and we'll install some familiar components like the Istio-D control plane. It installs ingress gateways as well. And then we'll come to some of the new components like the Z-tunnel that we've been talking about. And if I come back here and we look to the bottom pane, we see that Istio system has been installed as a namespace. And if I click into that namespace, we see some components that run as a CNI plugin on the node. We see the Istio-D control plane, and we see the Z-tunnel agents that are deployed in a daemon set, one per node. Now, the next thing we're going to do is we're going to add our applications in the default namespace to this ambient mesh. So that what we're going to do is label the default namespace with ambient mode or data plane mode, which is equivalent to ambient. And now we'll automatically add the workloads that are in the default namespace. These services are going to go into the ambient mesh. But if you notice, there are no sidecars. In fact, these applications have been running for a while, so we didn't have to restart them or inject anything into them. We didn't have to change their descriptors or anything. But if we come into the sleep application, which we see is running on the ambient worker node, and we exec into that, and we come back down here to this pane, we find that the Z-tunnel that's running on the ambient worker node, and let's say we watch its logs. Let's do that full screen. And if we now do our curl to hello world, then what we should see is traffic that's now going through the Z-tunnel. And if you look a little bit closer at the logs, we can see things like while it's trying to do some mutual TLS, or it's invoking SPIFFE and establishing mutual TLS, let's take a look at a closer look when we make those calls through the Z-tunnel. So what does that actually look like? So we're going to do a kubectl debug in the Istio system namespace around the Z-tunnel, and we will use netshoot to help us understand what's going on here. So let's take a look at this. And let's come back here and let's make a call, a couple of calls actually, just to capture some traffic between sleep and hello world. And we'll stop now. We probably have enough traffic. And let's come back a little farther up here. We should see that when the traffic is going through, here we see traffic getting to the Z-tunnel. And then when it gets there, we have TLS encryption. Okay, so the traffic going over the Z-tunnels, we get mutual TLS between the sleep and the hello world service. And as a reminder, we didn't inject any sidecars into these workloads. We didn't have to restart those workloads. All we've done in ambient mode is we've been able to include those workloads and the communication between them as part of the service mesh. Now, a big part of the service mesh is also enabling layer 7 capabilities. And so that's where the waypoint proxy or the layer 7 capabilities of the ambient mesh comes into the picture. So instead of the traffic passing between these tunnels, we can actually pass them and hand them off to a layer 7 envoy proxy, which then implements certain capabilities like retries, fault injection, header-based manipulations, and so forth. In this demo, we're going to deploy a waypoint proxy, and we're going to inject a layer 7 policy fault injection. In this case, we'll observe how we can implement layer 7 capabilities in the service mesh in ambient mode without sidecars. So to do this, let's get out of TermShark. And now we're going to apply a waypoint proxy. And so let's take a look at that. This is the layer 7 proxy for the Hello World services. So one thing you'll notice is we don't try to share layer 7 components between different identities. We want to keep those separate and try and avoid noisy neighbor problems. So we can create this waypoint proxy by applying this, and then we should see a new proxy come up that would enable us to write layer 7 policies about traffic going into the Hello World service. So now if I come back, we can take a look at a virtual service, which is a familiar API in Istio that specifies traffic rules when a client tries to talk to Hello World. And in this case, we'll do some layer 7 matching, and then we'll do some fault injection. So 100% of the time, we will delay the calls by 5 seconds. So let's apply this virtual service. And then we'll go back to our client. And so now when we call the Hello World service, we should see a delay of 1, 2, 3, 4, 5 seconds. And we should see that potentially load balance across both V1 and V2. So as you can see, we get layer 7 capabilities, we get layer 4 capabilities in mutual TLS, and we can write policies about this communication between these services, and we have not touched the applications. We can include them and even exclude them dynamically. So if we're done with this service and we don't want it anymore, then all we have to do is just uninstall it. And then we'll remove the system namespace and come back to our applications. And we see that they're not touched. Go into one of the applications, we make a call, and then without Ambient in place, the services continue to work just as we expected. So thank you for watching this demo. So to summarize what we've seen so far with Istio Ambient Mesh, both from a presentation and a demonstration standpoint, 3 core benefits remain, right? We want to reduce cost. We want to, perhaps most importantly, simplify operations. We want to make the service mesh truly transparent to applications, decouple the proxy from the applications and just make it part of the core infrastructure, and so simplifying doing things like application updates. And we want to improve performance as well by taking advantage of this new proxy configuration that allows us to just bite off on the functionality that we need for our particular use cases. So what are the responses that we've seen to Ambient Mesh so far? I think the general responses have been very positive. Occasionally there's been a wait and see, yeah, this is interesting, but let's see it in production before we get too excited. This is the one that I think is really interesting. This is from Matt Klein. Matt Klein is at Lyft and was the founder of Envoy Proxy, built it back in the mid-2010s. And he says, this is the right path forward. Sidecars have been an unfortunate implementation detail in the past, and now we're going to see mesh features that get absorbed into the underlying infrastructure. Excited to see how this evolves. Going back to our quote from the beginning of this talk from Joe Searcy at T-Mobile, he says the opportunities that Ambient Mesh provides are extremely exciting, better transparency for applications, fewer moving parts, simpler invocation, huge potential in savings of compute resources and engineering hours. Those are all really good things. And there's at least one episode of unintentional humor. So this is from the CEO of a company that leads the Linkerd community, which is kind of a double down on its sidecar-based architecture. And so he actually put out kind of a joke tweet in response to all of the chatter around Ambient Mesh and said, hey, by the way, Linkerd, we're actually going to switch to having a sidecarless option as well. Kind of put some things in there to try to provide hints that he was joking. But you can see, a day or two later, people realized, he realized people weren't getting the joke. And so he had to come back and say, yeah, this is a joke. We really like sidecars with Linkerd. So that was some fun that came out of this whole announcement process. So what's next beyond this in Service Mesh? There are two capabilities I want to talk about, both of them on the data plane. That's where we see a lot of the innovation happening these days, is in the data plane itself. And so one of the things we want to be able to do is to improve the performance of these new components. So what we did for the experimental implementation that's out there now is with the Z tunnels. Those are implemented as Envoy proxies that are just configured to operate at level 4. But there are some additional opportunities for increasing performance of that even more. And so what we see is being able to perhaps replace the Envoy proxy there with an even lighter weight Z tunnel implementation, even using technologies like eBPF. So eBPF allows us to do things like packet filtering in the kernel of the operating system. And so it's extremely efficient. It's not something that'll be a revolution in terms of what's going on here. The architecture is going to remain the same, but just providing a more efficient implementation based on eBPF to actually make those Z tunnels run even faster than they do today. One other thing I want to talk about here is kind of a different level of innovation. We've talked a lot about the architecture of the data path, but I also want to talk about there's a lot of innovation happening with Service Mesh at the edge of the mesh as well. So one really good example of that I'm excited about is GraphQL innovation. Just very quickly, with GraphQL today, what we typically see in enterprises who deploy it is you have an architecture that looks roughly like what's on the right here. So you have an API gateway, something that's like you've been using before, that serves up your REST interfaces and your maybe gRPC, whatever kind of APIs you have out there. But then you end up having to build this separate server component that knows just about GraphQL, how to assemble GraphQL responses from underlying services and that sort of thing. And we're not sure that's the best approach. Like, what if you could have GraphQL APIs that don't require dedicated servers? What if you could reuse existing API gateways to serve GraphQL? It's like they already serve, OpenAPI, gRPC, other kinds of interfaces. Why can't they serve GraphQL as well? Why do we need to stand up a separate server component or set of server components in order to enable GraphQL? That doesn't make a lot of sense. And what if you could do that in a way that would allow things like declarative configuration, as well as leveraging your existing API contracts? And so, Solo's done a lot of work in this space, specifically in a service mesh context. And so, basically, the takeaway from the story is, what if you could actually absorb the GraphQL server capability into a filter in your Envoy proxy at the edge of your network? Basically, inspect existing applications and their interface contracts, derive GraphQL schema from that, be able to stitch those together to create a super graph that spans multiple services, and deploy those in an API gateway. We think that's a powerful innovation for a very growing in popularity API standard in GraphQL. All right, if you would like to learn more about any of the things we've talked today, especially Ambient Mesh, I definitely recommend this resource. There's a bit.ly link that will take you there. This is a completely free book from O'Reilly, written by a couple of people at Solo and basically goes through in a fair amount of detail Istio ambient mesh and will help you understand exactly what the objectives and implementation are there. There is also a hands-on workshop if you're like me and you like to get your hands on the keyboard to understand this stuff better. I encourage you to follow that to bit.ly link there, bit.ly/ambient-workshop. It'll take you through a hands-on exercise for getting started with ambient mesh. Okay. Now back to our original story. All right. So what happened? We got to the finals and we had the big behemoth design against, with the committee and so forth and the little tiny car with the single designer. Who won the day? Well, I'm happy to report that. So the behemoth designers, they got in there at the starting line. 2 people carry it up to the starting gate. They twist up all the potentiometers to make it run as fast as possible. Well, they spun it up a little too much, and the thing actually goes careening off the track. And the little car just kind of shuffles its way around the track, and it wins the day, much to the delight of all the college students who were there watching the finals of this competition. So in my view, there was a happy ending. David beat Goliath, and parsimony and simplicity won the day. And that's what we think is going to happen in the service mesh community as well, is that simplicity and ambient mesh are going to be ruling the day very soon. So I thank you very much for your time today. I hope you got something out of this talk, and look forward to answering your questions.
So great presentation. I had a lot of questions. I think you answered everything in the chat. People are welcome to ask some more questions. We're going to stick around for another 5 minutes or so. If you have any more questions, please post them. I've got a few lined up just to keep this going. Sure. You mentioned that the 3 pillars were secure, connect, and observe. I got this out of order. The ambient mesh really seemed to focus on reducing the complexity, and it helps for those connections, and then the security doesn't have to be configured as many places. Does it help the observability as well?
Yeah, absolutely. I'm not sure that ambient per se really addresses so much the observability concerns. There's a ton of metrics that already get published out of Istio and Envoy proxy. If you've ever done anything with Envoy proxy, whether in a service mesh context or not, you'll know that there's just a raft of metrics that get published there. So I don't think ambient really is going to enhance the observability per se, but it does just allow that to be delivered in a more cost-efficient fashion.
Gotcha. One more question came in. Do you see any service mesh deployments that aren't using Kubernetes?
Yeah, that's a great question. We definitely, I know in Solo's business, we have, I mean, obviously, no one at the kind of scale that I expect the people on this session are managing. You're not dealing with green fields. And so definitely Istio has a lot of best practices established around non-service mesh deployments. We blog about it quite a bit at Solo because these are the kinds of real world issues that we encounter. So I would say this. I would not recommend trying to deploy Istio without any kind of Kubernetes context at all. In other words, if Kubernetes is not part of the strategic direction of your organization, then I wouldn't recommend going there. But definitely, if you're in a mode like a lot of the organizations we deal with, where this is our objective, is to move toward Kubernetes and cloud native and Istio service mesh sorts of deployments, then definitely can accommodate services that are deployed in VMs or EC2s or wherever.
Gotcha. So if you're doing the migration from a monolith architecture and breaking it up into microservices, this is probably something to be thinking about. Yeah. Should it be one of the very first things you do, or should you figure out and learn Kubernetes first and then layer on the Istio?
Yeah, I'd say anytime you're contemplating a major organizational change, and this is independent of Kubernetes or service mesh, right? It's start small, ideally. Start with something where you can wrap your mind around it and kind of understand it, and that's non-critical, and that you can kind of manage you can kind of manage the situation, and then over time layer in additional complexity and outside outside elements and that sort of thing. So just as a general rule, I think that's a good idea.
Gotcha. So eBPF, the extended Berkeley packet filters, like even saying the acronym seems hard to me. it seems like one of those really low level things that somebody's really excited about, but me as an application developer and architect, I don't want to have to learn that. Is that something that you see eventually becoming something that's sold as a package? Like, oh, just get this add-in and it adds eBPF. So it's the thing that you had before, but now it's lower level. So it's faster.
I think, yeah, I think you hit it exactly right. It's like I drive a car, right? I know very little about the internals of how an internal combustion engine operates, right? It's something that just exists below the level of abstraction I care about. And I'd say for the majority of people who are consumers of service mesh technology, I'd say the same would be true of eBPF, right? It provides a critical service. It's going to make things run faster. But I'd say it's going to be below the level that most people are consciously dealing with. There are exceptions. And in fact, we, Solo offers, if you go to academy.solo.io, you'll see courses on eBPF. So you can learn more about it. There are people who clearly need to be able to understand it. But generally speaking, we think that's just, again, that would be commoditized, just baked into the service mesh layers. I know that Istio is clearly moving in that direction. I think some of the other alternatives that are out there, I know Kuma's moving in that direction, and probably some others as well.
Gotcha. There's another question here about Istio seems to be synchronous in terms of communication. Does that come with scaling concerns? And for async, can consumers control the rate of request consumption? Is that possible out of the box, or does he even have it in the right context? It's about messaging and queuing solution.
Yeah, that's a big discussion. It's definitely you can definitely use Istio with asynchronous sorts of models. There's no question about that. And I think I kind of view those two independently. I've done a lot of work building enterprise systems over the years, and frequently, we'll move into an asynchronous mode for applications that require extreme degrees of scalability and where the use case kind of fits that. So definitely, Istio can be used in context of both synchronous and asynchronous services. And yeah, it's the whole idea with Istio and with any service mesh is to be as transparent as possible,
right,
to the underlying applications, right? In the ideal world, it's like an official at a sporting event. Ideally, I want to be there to enjoy the sporting event. I don't want to watch guys in striped shirts blow whistles, right? That's not my goal.
Yeah. So it should get out of the way, and like you said, a good abstraction. You don't have to know about the details of how it's doing it, but it shouldn't also raise up to the level of your application has to know about all the Istio plumbing that's there to be properly implemented.
Absolutely right.
I think just to tie on one last thing, you started to tease at the end, there's future of GraphQL changes, just because the last presentation today was about GraphQL.
Sure.
Where is that in the pipeline? Is that, in the works? Is it a year out?
It's definitely not a year out. So I can speak with some authority to what Solo is doing in that space. So Solo has a couple of products in this space. One is a standalone application gateway it integrates with Istio, but does not require Istio. And in that environment, there's a full GraphQL solution that's already there that basically allows you to absorb GraphQL server capabilities up into the Envoy proxy. There's essentially a beta version of that's available in Solo's commercial service mesh product that's based on Istio as well. That'll be full implementation within a couple of months. So yeah, it's really exciting stuff. We see we see massive migrations of people toward GraphQL as an API standard, and we think a lot of the architectural decisions that are coming along with that are a little unfortunate. They don't make a lot of sense to me. Why would we want a separate type of API server instance to serve up this API when we already have something that serves up, REST and Open API and gRPC and so forth? Why can't we bring those all together?
Yep, definitely something to look forward to. Well, we are over time, and I appreciate everyone for sticking around to the end of the day. Jim, thanks again for speaking. I hope you guys enjoy the rest of QCon Plus next week.
All right. Thank you all. See you around.